ERPs, MPS included, really work the same way. It's a planning engine. It's just the look and feel. Business Central is obviously a little bit more modern than most, which is very nice, and has some functionality that differs from a lot of other ERPs. But before we kind of get into the planning worksheet, which is what Business Central calls planning, they call it a worksheet. I'm going to go first to just an item, because with planning in general, it really starts with data. It's the old GIGO philosophy. So it's garbage in, garbage out. If your master data is inaccurate, well, then the output of your plan will be inaccurate. It's really as simple as that. But it's often very, very difficult for companies to maintain a very accurate plan because of the needed data accuracy. They can't keep up with it because it touches so many functional areas. When you talk about planning, it affects sourcing, procurement, receiving, everybody within production, manufacturing engineers, scheduling. So many different functional areas play a part in this, and it's all based on master data, but also everything that's recorded in WIP. So whether they're recording labor in real time, they're backflushing labor or backflushing material, all of these business decisions play such a critical role in how they're going to develop and maintain a plan. There's strategy involved here. But just to start from the beginning, I'll just go to an item, just any one of them here. And on this bike here I selected, we'll just go down to in Business Central, which is actually quite nice and very, very different, is that we have two different categories here, one called replenishment and the other called planning. They are different because manufacturing in Business Central is an option. It's not part of the base subscription. It's an additional subscription, part of the premium package. So it's actually quite nice that they allow users to differentiate these two categories. But first, with planning, it all starts with the item setup, the master data. So the master data includes your item master here that we're looking at, your routing, so your standard routing, your standard bill of materials, and then your order policies, which in Business Central reside right here on the item card. It's not a separate extension. It's not anywhere else in the system. It's all right here in your item master, which is very unique, actually. So with replenishment, this is really just the source of the item. So in the industry, we call this, what's the source? What's the item source? It's right here. It's just called the replenishment system in Business Central. Is it manufactured? Is it purchased? Or is it assembled? The replenishment system is where we have to start. We have to tell the system what the source of the item is, so it can. So the planning engine can then tell the user how to replenish the item. Is it going to be a purchase signal, a manufacturing signal, or an assembly signal? So it all starts right here. There's a lead time that is very, very critical, especially for purchase components. If the item is purchased, we need to tell the system how long it takes to get in-house. If there's a primary vendor or default vendor, we can list that right here, all within replenishment. And then if it is manufactured, is it make to stock or make to order? So make to stock is interchangeable. We're technically building that to inventory, not to support any single sales order. Stock's interchangeable. So if I'm building this to inventory, it could support one sales order tomorrow, and then the planning engine has the ability to repurpose it to support a different sales order the next day based on demand, new demand, changes in demand, and demand date. So stock, you have the ultimate flexibility. Make to order is we're building this bike, in this example, for this specific customer on this specific sales order. There's that hard link. Typically, you do not stock make to order. Maybe it's too costly, and you just want the sales order demand to drive the production for the finished good. You do not want to have any stock policies on the item. And then same thing on the assembly side. You can have assemble to order or assemble to stock. Typically, if you're using manufacturing, though, in Business Central, you would not use assemblies. Manufacturers like to stick with manufacturing. If you do not have manufacturing in Business Central, then you certainly have the capability to just use assemblies and assembly orders. And again, assemblies are just a collection of items that do not require a routing. There's no series of steps. You do not account for labor and no whip tracking. It's just quickly maybe building a kit, something like that. And now we move down to the planning section here on the item card. And this is where we have our order policies. So in the industry, we call all of this order policies or lot sizing requirements for on the manufacturing side. Order policies more on the purchasing side. And this is where we define all of that. And in Business Central, we have really 4 different types of order policies. So fixed reorder quantity and maximum order quantity really have to do with inventory and managing inventory levels, since inventory is really the first consideration for effective planning. So what the planning engine does, it looks at the top level and explodes downward when it plans. But in fact, we work the opposite. We actually work from the bottom up. We build from the bottom up. So this is where the strategy comes into play. It depends on if we've got, let's say, a 5-level product structure. Usually at the raw material level, there's commonality. So if I'm just taking such as a 12 gauge sheet of steel, I'm using that 12 gauge sheet to cut many different parts. So there's commonality. So I might have a safety stock level on that raw material, and I want the system to tell me just when I need to replenish the inventory because the turnover is so high. I can use that same strategy on subassemblies, maybe somewhere above the raw material level, somewhere maybe in the middle of the product structure. We don't typically use these with finished goods just because it's the highest risk. It's typically the most costly. If you safety stock finished goods, you're carrying finished goods inventory, which most companies do not want to do. It's not as intelligent to do that. But the first 2 order policies usually have to do with inventory, and that's just meaning your stock components, like your raw materials. How do we want to manage that? Fixed order quantity policy is just really saying every time I need to replenish this item, I'm going to do it in this particular lot size. In this case, it looks like it's 100 pieces each. So let's say I have a reorder point of 100 as well. As soon as my inventory level, my projected inventory level is going to dip below 100, the system planning is going to fire off a signal to me to replenish my inventory in a quantity of 100, and it will not deviate from that because that's my fixed reorder quantity. So it's automatic inventory management based on the strategy you have in place. Now, with inventoried items, it's not as easy as it might sound. Reorder point and safety stock down here can be considered the same, but they actually are not. Business Central sees reorder point as looking at your projected inventory and saying when it dips below this input, I am then going to recommend we replenish that inventory based on this quantity here. So what that means is it's going to send a signal the next time bucket into the future to replenish the inventory. So there's going to be a lag, a delay there. So it's that next time bucket plus lead time. So it will allow you to deplete your inventory lower than the reorder point. Where the strategy comes into play is you need to make sure this reorder point is high enough where you do not fully exhaust your inventory level, then you're in trouble. That's where safety stock can come into play. Where safety stock, the system sees that as a little different. It's a hard stop. So if I've got safety stock of, let's say, 100 in here, the system looks at it differently. It's actually looking at your projected available balance, not your projected balance. So it's looking at what obviously your inventory level is, plus what might be pegged to other demand orders. So what might be reserved already into the future based on your time buckets. And the system does not want you to dip below your safety stock. If it's 100, the system wants you to have 100 pieces in inventory at all time to account for that odd situations where we have severe demand spikes, because by definition, safety stock is additive demand. So if you're constantly draining your reorder point or your safety stock for that matter, then they're not working for you. Your strategy is not working for you, and we need to reassess that. Typically, reorder point and or safety stock, depending on which one you use, you need to do some usage analysis on your inventory. And what I always recommend doing when I used to do this in the plant was figure out what my average usage is throughout the year, keep a rolling 12-month, then add 2 standard deviation to that so that my safety stock is actually covering me 97% of the time, not 50% of the time. If your safety stock and reorder points only covering you 50% of the time, it's not working. It's as simple as that. So you need to do some math, some analysis behind that to figure out what these inputs should be. They're going to be different for every company, and whether or not they actually use them. Just depends on the environment. With your max order quantity, another inventory policy here. This is really quite nice. A lot of systems don't offer this. BC does, and this is another way to manage inventory with a min-max. So you can have your reorder point of 100 and your max at 200, just in case you wanted to keep your inventory level between 2 points, which is quite nice that the system offers this. And a lot of the times you see this in med device because you might have agreements with your customers to keep a min-max inventory level. So it's very common in certain industries where, yeah, we have contracts where we have to keep a min-max. Here's where you can do that. You can tell the system what those min-max inputs are, and the system will maintain an inventory level between the two. And then, of course, you can have an order policy in addition to that. So if it dips below your max, which is equivalent to your overflow level right here, let's say that is 200, as soon as it gets to, let's say, 175, the planning engine will fire off a signal to the planner to replenish your inventory by a certain amount, and you define that certain amount here. And this is your min order quantity, your maximum order quantity, or simply just a multiple. You can use any combination of the three. It just depends on the part. A very simple example is a box. I cannot buy one screw. I need to buy a box of 100. So therefore, your order multiple in this case might be 100, or your min max might be 100, 100. So the system never deviates. It's always gonna, if you need 200, it's gonna fire off 2 signals for 2 boxes of 100 screws each if you use min max. Order multiple of 100 would say, okay, I'm going to fire 1 purchasing signal to buy 500 screws. That would be 5 boxes. So it just depends on the part, and then up to the planners in the business to make that decision. Same thing on the manufacturing side. If we need to build in a certain lot size because it's economical for us to do that, we identify that right here. If you do not want the system to deviate on manufacturing production order, we can do that right here. If we can have 100 and 100 as our min-max, that way the system's only going to recommend production orders in quantities of 100. That's it. Perhaps so we don't tie up machines or work centers for very long, maintain that manufacturing flexibility out there on the floor, rather than have one production order of maybe 2,000. It's going to sit in on a machine for too long. So it just depends, again, on the part. The other 2 order policies here, order for order and lot for lot. So order for order, that's again goes similarly back up to the make to stock, or excuse me, make to order replenishment policy up here. So it's for those that are using manufacturing and using the planning worksheet. Order for order means there's that hard link from supply to demand. So the system does not have the flexibility at all to move, let's say, this production order 1 bit. This production order has a hard link to this sales order item. The planning engine will not move it or repurpose it to support any other demand, even if a new demand is entered sooner, needed sooner. It will not move it. It will create a new order. So this is that hard link, and out in the field in the industry we call that pegging, supply demand pegging. In Business Central, it's called order tracking. Same thing. So that's order for order. It's just that hard link. Lot for lot, you can use this for make to order or even buy to order parts. What this is doing is actually telling the system to look a little bit further out into the future, and all of the demand that I have within this period, just create me one supply order. So it's a way to minimize supply count for make to order or buy to order items. So lot for lot, again, is just saying I don't necessarily want inventory on whatever this item is again a bike in this example. I don't want inventory on it, but I don't want to build just one. I want to tell the system to look out maybe 2 weeks into the future. And for all the bike orders that I have, just create me one production order to build them all at once. And we identified here as lot for lot, and also by identifying our right down here, our lot accumulation period. This is the time bucket for non-inventoried items. So the lot accumulation period is telling the system how far out into the future to look in order to group my supply. In the field, in the industry, this is called your day's supply or supply days. So in BC, it's just lot accumulation period. How far out in the future do we want to look when it creates supply? So a really nice way to still maintain a limit on your supply, even for non-inventoried items. It's beautiful. It's a very nice feature that BC offers that a lot of other systems simply do not. Because one of the challenges in production that most companies deal with every day, what's one of the number one things that production managers hate? A ton of job orders out there on the shop floor. It's more maintenance. It's more for them to manage. Operators, cell leaders, supervisors get overwhelmed in an attempt to sequence that work effectively. They just can't do it. So by minimizing the supply count, it really helps the sequencing of the work by all the folks out there on the shop floor. The time bucket for inventoried items. So if we go back to fixed reorder quantity and maximum order quantity, this is our inventory selections here. The time bucket is simply just time bucket. This is your day supply input for inventory items. And here it looks like we got 1 week for this item. And that, again, that's just telling the system how far out into the future to look for inventory items when it creates a new supply signal. So again, just another way to limit supply count on the inventory side. You do have your safety lead time here, which is nice. This applies to both purchased and manufactured items. So in the industry, this is called a buffer, which gets you to start a little bit earlier than you would otherwise, which is really, really nice. So a lot of people refer this to as maybe a shipping buffer because they apply it to top level finished good items. And then it obviously would trickle down to all of the subassemblies and components underneath that. So it's going to get the work started a little bit earlier to protect you against lateness or disruption in WIP, like we experience every day in manufacturing, whether it's a resource being out, a machine being down, late material, inaccuracy in routings, because routings are always estimated. Also depends on who you might have working on the item, an experienced hire or an apprentice, someone like that. So this is your buffer. So for instance, if you have a 2-day safety lead time buffer in here, that's quite nice. It's telling the system that if it takes me 5 days to build something and it's due in 10 days, rather than start it on day 5 to finish on day 10, what the system would then recommend is let's start this on day 3 to finish on day 8, ahead of the demand date of day 10. So it provides 2 days of wiggle room to account for all of those disturbances I mentioned. So that's actually really critical that I think a lot of manufacturers should strongly consider. And there are other options to us to build in WIP queue and other buffers, but those are in WIP or on purchase items. This is the downstream buffer option right here. So that's this is kind of where it all starts to have and to start yourself off with an effective plan is getting everything on the item master input correctly. There's often strategy in here. What items are we talking about? What level in the product structure? It usually requires a lot of guidance to make these inputs correct so that you have the correct output from the planning engine. So that's the item master. And then in addition to that, we need accurate routings, and these are estimated. So with routings, they're never going to be perfect ever. There's just too much variability with resources that we just want them to be as accurate as we can get them, as accurate as possible, so that it provides the best plan to us. Because the lead time for manufactured parts is the routing. So if we're way off here in our routing, then obviously the plan for the part is going to be way off. It's really as simple as that. So having strong and run times in here, cycle times, I should say, because the cycle time is a combination of 4 inputs: setup, run, wait, and move time. So having strong cycle times in our routings is obviously very critical. And then I'll just bring up a BOM, so a bill of material. The most important thing here is making sure that the structure is accurate, meaning that we have the dependency built in for planning, so that we have all of our subassemblies and components identified with the right low-level code, so that the system can plan top-down, but we release and build from the bottom up. So therefore, we work on obviously purchasing our raw materials first if we need to, if it's not already in inventory. If it is, then we issue that to the lower level job. We release that order, work on that, complete that, then release the next production level up from there. So we manage WIP based on how we release orders. We don't want to flood the pipe. If we release everything once, way in advance, all we're doing is creating chaos. We're going to overwhelm the shop floor, and then the planning and then scheduling systems, if we are using scheduling, is going to not work for us. We need to limit the number of released orders we have out there on the shop floor so that the system can work for us. A lot of the times in a lot of companies, I see that they release orders way too early. As soon as the production order is created, they release it. They release everything in mass, and that's not good. Even if they won't even start the work for weeks, or maybe even months in some cases, there's no reason to release that production order. If we keep that in plan status, the system will maintain the flexibility for us. As soon as we release it, we hamstring ourselves. Then the system, you've limited its flexibility to make changes on that order, especially in the case if let's say the sales order was canceled. We've got a release production order out there. What if it's got material issued to it or labor on it? Nothing we can do about it. Now it's a business decision. Do we want to finish the order, put it back in inventory, and wait for the next one, or just absorb it and cancel it? So we really don't want to do that. It's something that I always try to advise clients on is don't jump the gun with releasing orders. Leave them in the industry, we call it open. Leave it open. And that's in Business Central, it's just planned. Leave it planned. Only release it when you need to. Only release it when you're ready to start the work. Most people don't realize that. You lose all the flexibility when you start releasing stuff prematurely. So that's really covers it for the master data, high level here. You got the item master inputs, the routing, order policies, and bill of materials. And now let me just take you to the planning engine itself in Business Central. I have it up here somewhere. Here we go. And this is what it looks like. So here's it's in Business Central. It's just called the planning worksheet. So it first starts with generating a plan. So what we'll do is, and I've already ran one here to save time, but under prepare, we just hit this calculate plan. You get this window that comes up here that tells the system how are we planning? How do we want it run? MPS is master production schedule. That really pertains to top level finished good items. MRP is what really planning in general has been called for many years out in the industry. We just call it MRP or planning. MPS is just another component of it. So when most people refer to MRP, it's both. They don't differentiate the two. In my mind, why would we want to plan only the finished good? Especially if we've got many components underneath it, we should plan everything together. So MPS and MRP are really should be run together in my mind in almost every case. But you do have the option to run just the components or just the top levels. And then our start dates. Here's our horizon. So we call this the planning horizon. In Business Central, it's just starting and end date. It's up to you on when you want the plan to start. I suppose this would reference how many late orders you actually have. First and foremost, do you have demand that has not been fulfilled that is in the past? Well, then our start date should probably be in the past, so that's incorporated, because if you start with today's date, the system will automatically think that late orders have been fulfilled, which might not be the case, and that's a struggle of many companies. Actually, is lateness, and it's a result of poor planning and poor scheduling. So this is what the system aids them in correcting. So identifying your planning horizon, I always recommend this should be your longest purchasing plus manufacturing lead time and then some. If you're not covering that, you're not doing yourself justice. So longest purchasing plus manufacturing lead time, and then in some environments I say double that, because it also depends on if you forecast. Are we forecasting? At what level are we forecasting? Are we forecasting finished goods? Are we forecasting subassemblies, components? With forecasting, that could be a whole nother discussion. It's another strategy on how to forecast. I quickly always recommend forecasting at the lowest level you can go. There's less risk, it's less costly, and you probably have better usage analysis on your components than you do with subassemblies, obviously. If you forecast the top level, then it's much higher risk. You run the risk of sitting on finished goods inventory, which is costly. You always want to forecast parts with commonality, similar to what I mentioned with safety stock. That 12 gauge sheet of steel I mentioned is used to make many finished goods. So forecast that. You've got better usage analysis on that. There's higher turns on your raw material, so forecast the raw material. Have that available inventory for you, and then let sales order demand drive production. That's your horizon. And then again, if you're forecasting, which is very nice, Business Central allows you to actually upload or enter many different forecasts. And you can tell the system which forecast you want to use within this planning run. A lot of systems do not allow for this. And then, of course, if you wanted to just plan, a certain item or a range of items, you could. You could limit the plan right here just by using your filters. Typically, you run a plan for everything. You want to plan the shop or the location. And again, it depends on the environment, the business. How often are we planning? I always like to plan every day. You're entering sales orders every day, aren't you? You're modifying inventory every day through adjustments or issues or whatever it is, movements. Why not incorporate that every day, right? Keep your plan current. When your plan falls behind is when you get yourself into trouble. I like planning every day. Doesn't mean you need to adjust the horizon, the start date, because your late orders might remain in the past, but we should run the engine every day so that our signals are up to date. But again, it's just up to the company. Some plan every day, schedule once a week. Just depends on the parts, how fast they move through WIP. And then we would hit OK to run it. I won't, since I already did. I'll cancel. And here's the output. So here's our plan. And a lot of these messages here for us. There's some warnings, meaning exceptions, attention, Emergency, you would get, I don't know if I got any emergencies. It doesn't look like it. But a lot of it just depends on the state of the item. So emergency would be like more on the demand side. If demand fell into the past and is unsupported or unfulfilled, then it's an emergency because there's a customer order sitting out there that you should ship. Attention would more be on the supply side. So if you have fallout or something like that and you don't have enough supply to meet the demand, but it's not past due, it's into the future, it would require your attention. Exception is if you ran yourself negative or something in inventory maybe is off. Maybe a user did some poor transactions, incorrect transactions, something like that. But what the system's trying to do is help you. It wants you to look into every single one of these messages and take action. Accept it, ignore it. In some instances, maybe you know something that the system does not because it doesn't have the data. But you know, so you can ignore it if you wanted to. But here are all these warning messages. Let's just go to some with new supply. So here, simple example, somebody entered a sales order last night and I run planning this morning. First thing this morning, planning, what does it do? It creates new supply to support that demand. Somebody entered a demand for a touring bicycle, and look at that. The planning engine just created a new production order to build it. So the source of your item is right over here. The reference doc is in here too, so you can peg it. We call it pegging, and Business Central is called order tracking. So you can find out what the relationship is between supply and demand. Why am I building this bike? The system will tell you why you're building the bike, because it was ordered on this sales order number. So there's justification, there's demand justification with everything within planning. And high level, you can think of planning as material management. Planning manages the material. It is infinite. Planning's job is to make sure that supply is equal or exceeds demand based on policy. That's planning's job. It is infinite, so therefore it can go into the past. Scheduling is quite a bit more complicated actually, because scheduling is finite. Scheduling is the one that realizes true material and capacity constraints. It recognizes what you can and can't do out there on the shop floor. Scheduling can only work into the future from this moment forward. So an example would be if you have something due in 5 days, but it takes you 10 days to build it, planning would say, oh, just start this 5 days ago. That's not possible. What scheduling would do, if you're using advanced scheduling, would say we can start this today and finish in 10 days, therefore you're 5 days late. Lateness is a metric of scheduling, not necessarily planning. But it all starts with planning. You have to plan before you schedule. You have to have a plan. Planning is managing the material so supply meets demand. Scheduling is then sequencing the plan. It sequences the work based on demand date, time. So within the planning worksheet in Business Central, which is a really nice feature, is you actually see these start and end date times. In Business Central, the plan actually does provide you infinite scheduling dates. These are ideal scheduling dates. Obviously, if we were to run an advanced schedule, it might modify these to make them more realistic, because the system might say, well, we don't have machine capacity on this day, so we have to work on this 3 days into the future, therefore we might be 3 days late. Planning doesn't necessarily know that because it's infinite, but it still does provide you these targets, which is very, very nice. A huge reference for when releasing orders. But what the system wants the planner or planners to do is review every single one of these messages and take action. And you can take action on these in mass. You don't have to do them one by one. You can just say process, carry out, message. I won't do that because I don't want to lose my data here. but you can say carry out for all of those selected here in this column. What Business Central does is it doesn't default the action message to be selected because it actually wants you to look into these individually, which is good. A lot of folks might disagree with me there or have gripes there because planners in general are, they have enough on their plate. It's a hard job. It is. Being a production planner is a very, very hard job. Those people are rare. And they might not have time to obviously review all. In this case, I've got a small data set. It might be thousands of messages. Nobody has time for that. The system wants you to review them individually, but planners might not have the time or might not want to do that. They just have to trust it. So that's just the reason why these don't come defaulted. The user would have to make the selection there to carry out the message. But you're going to have tons of message in here. It's like cancel. It wants you to cancel this one assembly order here, maybe because stock was found. There's no reason to assemble it anymore. Somebody made an inventory adjustment. Now we have inventory. We've got stock. Maybe the sales order was canceled, so we don't need the supply anymore. There could be, so now this is considered redundant. We call this redundant in manufacturing. We want to limit the number of redundant orders. We don't need them. The system is guiding us. It's helping us. It can see and do a lot more math than any one planners could every single day. Even if you get the best planner on their best day, they cannot do what this system's doing. So that's why I always say, look at all these action messages on my very small data set. Most businesses have thousands. Planning and scheduling is really the hardest thing to keep up with in manufacturing. And we can drill into order tracking, forecasting, and everything, the fact box, everything you see over here on the right-hand side, which provides high-level data on the item itself. We've got material availability, which is very, very nice. So again, there's demand justification for everything in here, like I mentioned, so you can drill into it and see based on bucket, individual, date, or demand, what the system is doing. Why did it create this for me? Well, here you go. Here's your justification. We're going to run ourselves negative if we don't create a new supply line to support whatever order this is on this date. So this is just by event. So by demand line. You can look at it individually by date. So we've got all the justification tools in here through our material availability, and we call it material availability. In Business Central, it's just called item availability. That's all. And then a really nice resource that planners always reference is order tracking. Right here, let's see if I can get one here. I landed on an example. I just went to the order tracking link through the related feature, really at the ribbon there. So now here we can see that this planning item right here was created to support this sales order. So it's linked. There's justification for everything. Even if it's stock, it doesn't have to be make to order. Even though it might be make to stock, there might not. There's a sales order for a stock item that we don't have an inventory. The system's going to tell you to build it. Technically, you're supporting inventory because it's stock, but it's just going to be a soft link to this sales order. This is the demand that's triggering the supply. So when we're done with the production order, we simply move it to inventory and then ship it out when the customer needs it based on the demand date on the sales order line. So there's a soft link, a soft peg, even for all stock. It maintains a relationship throughout the entire product structure. And then we can always drill in underneath the top level to see what supports this finished good that we're building. Okay. But planning is a big topic. A lot of inputs, and obviously you see a lot of outputs here. It's all driven by the individual company. What's the strategy? How do they manage their inventory today? Is it effective, not effective? Is there a better way to do it? What are their order policies? What's the accuracy of their master data? How do they plan today? How do they schedule today? A lot of different factors to consider with you implementing a planning engine. This is not a plug and play. You can't just turn this on. It typically takes significant business consulting and guidance to utilize planning in manufacturing, and then ongoing training to perfect it. It's a project in itself for sure.
Thanks for watching this Archer Point video. If you found it helpful, make sure to check out our website and blog at www.archerpoint.com. Additionally, if you have any questions regarding our products, services, or information in this video, feel free to email us at info@archerpoint.com. Thanks.